In this video, we will take a look at why if a vector v makes an angle theta with the positive x-axis, then a component form vector v has an x component equal to the magnitude of vector v times cosine theta, and a y component equal to the magnitude of vector v times sine theta. And we'll explain this using what we already know about right triangle trigonometry shown here on the right. And let's do this by working through an example. We're asked to find the component form of a vector with a magnitude of 8 and forms a 60-degree angle with the positive x-axis. So to begin, I've already sketched this vector in blue because the magnitude of the vector is 8. We know the length of the vector is 8 units. And because the direction is 60 degrees, or because the vector forms a 60-degree angle with the positive x-axis, we know this angle here is 60 degrees. For the next step, we can form a right triangle using the horizontal and vertical components of the given vector, where this horizontal vector here represents the horizontal component, which we can label x, and this vertical vector here represents the vertical component. Let's go ahead and label this y. Now if we find x and y using right triangle trigonometry, we will also find the x and y components of the given vector. For a quick review, remember, when we have a right triangle, cosine theta is equal to the ratio of the adjacent side to the hypotenuse, or if we are on the coordinate plane, cosine theta is equal to x divided by r, where r would be the radius of this circle here, centered to the origin, which also notices the magnitude of the vector, or the hypotenuse of the right triangle. So if we have cosine theta equals x divided by r, notice how we can solve for x by multiplying both sides by r, which gives us x equals r cosine theta. And x equals r cosine theta is equivalent to x equals the magnitude of vector v times cosine theta. Similarly, sine theta is equal to the ratio of the opposite side to the hypotenuse, or on the coordinate plane, sine theta is equal to y divided by r. Solving for y here, we get y equals r sine theta, and y equals r sine theta is equivalent to y equals the magnitude of vector v times sine theta. To show this, going back to the right triangle on the coordinate plane, notice how we can state that cosine 60 degrees is equal to x divided by 8. If we solve for x, we multiply both sides by 8, which gives us x equals 8 times cosine 60 degrees. And we know that 8 is the magnitude of vector v, and therefore this equation here is equivalent to x equals the magnitude of vector v times cosine theta. Similarly, using the right triangle, notice how sine 60 degrees is equal to y divided by 8. Multiplying both sides by 8 gives us y equals 8 sine 60 degrees. Y equals 8 sine 60 degrees is equivalent to y equals the magnitude of vector v times sine theta. Which is the reason why the given vector, vector v, has an x component of 8 cosine 60 degrees and a y component of 8 sine 60 degrees. And now we need to evaluate cosine 60 degrees and sine 60 degrees, either using a reference triangle or the unit circle. And let's review both. Using the 30, 60, 90 reference triangle shown here, because we are in the first quadrant, we know both legs will be positive, and therefore the cosine of 60 degrees is equal to 1 divided by 2, or 1/2, and sine 60 degrees is equal to square root of 3 divided by 2, or on the unit circle, the terminal side of 60 degrees intersects the unit circle at this point here, where on the unit circle x equals cosine theta and y equals sine theta, verifying cosine 60 degrees is equal to 1/2, and sine 60 degrees is equal to square root of 3 divided by 2. Which means the x component is equal to 8 times 1/2, and the y component is equal to 8 times square root of 3 divided by 2. Simplifying, 8 times 1/2 is equal to 4. The x component is equal to 4. For the y component, let's write 8 as a fraction with the denominator of 1. 8 and 2 share a common factor of 2. There's 1, 2, and 2, and 4 2's and 8. The y component is equal to 4 square root 3. So in future videos, we won't have to form right triangles as we did here. We can simply use the given formula shown here. I hope you found this helpful.